Hello students, welcome to Talk on Civil Engineering. Let us see how we can find the location of shear center or the distance of shear center from the channel, from the center of channel section, that is from O, from distance O to where the shear center is located for the given channel section. So this is a channel section which is symmetrical about XX, along XX axis. Okay. And for this channel section, we can easily locate the CG of CG for this section. So usually the CG lies over here, right? The CG lies over here. And coming to the shear center location, the shear center usually locates away from the channel section. So it will usually locate somewhere here. Okay, somewhere here. So we need to find out what is the distance or what is the eccentricity of this shear center, the shear center from O. Okay, and usually this shear center location will depends to balance the twisting or to balance the twisting of this channel section. So here you can see the shear flow within the section is something like a water here, something like water. So here you have a shear force in the flanges. So let it be FF, that is the shear force in flange, and it will flow upwards in the web. So let this be a shear force in web, and on top flange it will flow something like this. So let it be shear force in flange. Okay. So here if you observe the shear forces in flanges, so this shear force in top and bottom flanges is creating a couple something like this. So it is creating a couple. Because of this couple, the channel section will tends to twist. Okay, what is this couple? Can we figure it out, this couple? So what is this distance? You know, this is the outer to outer distance of outer to outer depth of the channel. So this is the total overall depth of the channel. Let it be a capital H. Okay, and this is the center to center depth. Let it be small h. Okay, now we can write the couple as F into H, that is the shear flow in flanges into H will make the couple which is acting in clockwise direction. Okay, so this couple will tends to twist the channel section. So try to remember that. And the resultant shear force of this channel section will be acting at the shear center. So somewhere here. So this is our shear center. So here the resultant shear force F will be acting. Okay, and this Fw will be will become 0 because it is counteracting the shear force, or it is acting along the will be acting parallel to the web, and it is acting from a center from that is from O itself. Okay, and let us take the moments about O. So here if you see the resultant shear force F, it is acting anti-clockwise direction. So the moment due to this F, so the couple due to F will be F into E, so which is acting anti-clockwise. Okay, now if we write the moments about O, so if we write moments about O, we can write F into E equal to FF into H, and this FW into 0 because it is acting through O itself. So we can eliminate this term. So it will be F into E equal to FF into H. So we can write it as E equal to FFH divided by capital F. Okay. So this is the eccentricity where the shear center is located. Let it be equation 1. And what is FF? So FF is nothing but your shear force in flanges, right? It is the shear force in flanges. Okay, and we can derive this, or we can find this shear force by multiplying the shear stress with whatever the area, whatever the difference in area of the flanges. Okay, now firstly let us try to find out what is the shear stress in flanges. So this is the shear stress in flanges. Okay, that is tau f. So tau f we can derive using a simple shear stress formula, that is shear force, that F into area y bar by Ixx into B. Okay, and let us consider a small elementary section in flange. So here I am considering a small elementary section of width dx and at a distance of x. Okay, and this will be my area. Okay, so now let me simplify this shear stress equation. So F into, so area will be x into TF. So here TF is the thickness of flanges. So here this is the thickness. TF is the thickness of flange. So here also having a flange of thickness TF, and let this be a thickness of web TW. Okay, so TF. So this is my area. What will be the y bar? So y bar will be the distance of the shear force from the CG, or from the CG axis. So this will be my y bar. Okay, so that is h by 2 divided by Ixx into, so here B will be my width of flange, that is TF. Okay, so here I can cancel TF. So it will be F into H divided by 2 times of Ixx, and here you have X also. So F H X divided by 2 times of Ixx. Okay, now we got the shear stress value. Now we can simply we can distribute this in shear force formula, that is FF is equal to tau F into integration 0 to x of dA. Okay, so if you simplify, if you substitute this tau F value, that is FHX divided by 2 times of Ixx and integration 0 to x, and this dA can be written as the width is dx, the small elementary area. I'm writing about the small elementary area. So dx is the width and thickness is TF. Okay, and we can rewrite this equation as FH to TF divided by 2 times of Ixx integration 0 to x and x into dx. Okay, so we can write like this, right? And let us simplify this. FF equal to FH TF divided by 2 times of Ixx, and if we integrate x, so it will be x square by 2, and the boundary conditions are, the limiting conditions are 0 to x. So the limits are 0 to x. So if you substitute 0 to x, the what is x here? X is nothing but b, right? So you can substitute from 0 to b. So here you can see So this is our B. Okay. So from 0 to B we can substitute. So let us substitute B. So it will be FHTF divided by 2 times of IXX into B square by 2, right? Because my limits are 0 to B. So if you substitute 0, it will become 0. So if I substitute B, so you will get this equation. Okay. So if you further simplify, it will become FHTF B square by 4 times of IXX. Okay. Now let us substitute this equation in equation 1. So substitute in equation 1. So if we substitute this in equation 1, so it will become yes. So here we have equation 1, that is E equal to FFH by F, right? So FF, what is FF? FF is FHTF B square by F into, here you have H, so I'm writing H. So here FF get cancelled, so it will become, sorry, under 4, sorry, I'm rewriting this equation once again. I have forgot to write 4 times of IX. So what is FF? FF is FHTF B square by 4 times of IXX into HF. Okay. Simply I have substituted FF value. So here FF get cancelled. So it will become H square TF B square by 4 times of IXX. Okay. So this is the equation to find out the eccentricity. So the final equation is E equal to H square TF B square by 4 times of IXX. So this is a simple equation to find out where the shear center is located in channel section. I hope you all have understood. Thank you all.